Here's an alternate way to look at problem number 5.3. First of all, we have to start off like we did before. We would say here's tension 1, here's tension 2, and here's tension 3. And if M is equal to 6 kilograms, what's the tension in string number 1? So we need to find out what's the tension in string number 3 first. So we would do a free body diagram of M. Realize that we have weight equal to mg pulling down, and we have tension 3 pulling up. The weight's equal to 6 times 9.8, so that is 58.8 newtons. And since summation of all the forces in the y direction will be 0, that's equal to the tension 3 minus the weight. So tension 3 is indeed equal to the weight, is equal to 58.8 newtons. Okay, so that's the tension in tension 3. Now, we wish to find the tension in tension 1 and 2. Here's an unusual way that we can solve this problem just by the fact that we're lucky enough to have a right angle between these two other tensions. Because if we were to now look at the knot and did a free body diagram of the knot, we could set this up in such a way that our y-axis was going along this direction and our x-axis was going along this direction. So that tension 1 is in the y direction, tension 2 is in the x direction, and the components of tension 3 will be in the x and y direction, the magnitude of tension 3 being, as we said, 58.8 newtons. So let's turn this around. Let's turn it this way. And so now we have a coordinate system that looks like this. So we have tension 2 totally in the x direction. We have tension 1 totally in the y direction, 90-degree angle between the two. And then we're breaking up tension 3 into two components, one in the x direction as we're writing it, and one into the y direction. Now, what are those components? Well, if I look at this original diagram here, I see that this angle here is 60 degrees, and it's intersecting with one of the components, and, well, it's intersecting with the main line to tension 3 and what we call the x-axis. So this angle here is 60 degrees as well. And that means that these two components, this will be tension 3 cosine 60, and this would be tension 3 sine 60. So we can see by this setup that the summation of the forces in the x direction should be equal to 0. That's equal to tension 2 minus tension 3 cosine 60. So I would say that tension 2 is equal to tension 3 cosine 60, which is 58.8 times 1/2, or 29.4 newtons. And the summation of the forces in the y direction should be 0. And that's equal to tension 1 minus tension 3 sine 60. So tension 1 will equal tension 3 sine 60. 58.8 times the sine of 60. And that gives us 50.9 newtons. So just because of the way this problem is set up, with just the freak coincidence of having a 90-degree angle between tension 1 and 2, we had an easier way to figure out what the tension was in tension 1, and it's 50.9 newtons.